Hey everyone, welcome back to part 2. Okay, check your answers for F and G from example 3 that we didn't finish from the part 1 video. Okay, please note cotan 1 over tan. Make sure you're in radian mode. Okay, and then you should have gotten negative 1.7321. Secant 1 over cos of 1,000 degrees, and we are in degree mode. Okay, so let's take a look at the next page. Okay, one thing we can do, and this comes up more so in, say, calculus, would be to express trig ratios of an angle in terms of a reference angle. Okay, so we're going to go through the procedure on how to do this, but let's just jump to example 4 and I can show you what I'm talking about here. So we're going to rewrite cos of 7 pi over 4 in terms of an acute angle, which means less than 90 degrees, or if we're in radians, less than pi over 2. Okay, in other words, use quadrant 1 really is what we want to be doing. So the same trig function. Okay, so first thing you want to do is figure out what quadrant 7 pi over 4, or whatever your angle is in. So 7 pi over 4 all the way around, 8 over 4, so we would be landing right here in quadrant 4. Then you determine if cos is positive or negative in quadrant 4. So cos we know is x over r. R is always positive, so it's really based on x. And x here, to plot a point in quadrant 4, x would be positive. Okay, so positive x. Okay, so that means if we use our reference angle, okay, so now we have to find the reference angle. That angle there, our reference angle would be pi over 4, okay, which we get by going, say, 8 pi over 4 minus 7 pi over 4, that's 1 pi over 4. Okay, so reference angle pi over 4. Okay, so we're going to rewrite this as the cos of pi over 4, meaning we're in quadrant 1 now, cos pi over 4. Okay, now if cos is the same sign in quadrant 1 as it is in quadrant 4, and we know it's positive in quadrant 4, and it's also positive in quadrant 1, then we could just say cos of 7 pi over 4 equals cos of pi over 4. All right, now we can test that on the calculator. What we can do is bring up the calculator and make sure we're in radian mode. Yes, we are. And just simply go cos of 7 pi over 4. See what that equals, and then go cos of pi over 4. And we get the same answer, exactly. Okay, so we know we've done that one correctly. Cos of 7 pi over 4 equals cos of pi over 4. Okay, let's try the next one here. Cotan negative 100 degrees. Okay, once again, let's find what quadrant that's in. Negative, we're rotating this way. 100 would land us just past negative 90, so we are in quadrant 3. Cotan we know is x over y. So x is negative in quadrant 3, y is negative, so the result would be positive. Okay, so we know positive, cotan is positive in that one. Okay, let's figure out our reference angle, which would be this. Okay, so we could get that easy enough just by going, say, 180 minus 100. Reference angle would be 80. So we're going to write this as the cotangent of 80 degrees, the reference angle. Now, cotan was positive here, and the cotangent of a rotation angle of 80 degrees would also be positive because we're in quadrant 1. Everything's positive. So there we go. You can test it on the calculator if you want. You'd have to go 1 divided by the tan of negative 100 equals, see if it equals, 1 over tan of 80. Okay, last one, sine of 11 pi over 2. Oh my goodness, 11 pi over 2. We've gone around a few times here, okay? Once around would be 4 pi over 2, right? That's the same as 2 pi. Okay, so if we take away 4 pi over 2, we'd be down to 7. If we take away another 4 pi over 2, we'd be down to 3 pi over 2, which we do know to be, oh, and it's positive, so 3 pi over 2 would land us right here. Tricky. What's the reference angle there? That would be just pi over 2 as the reference angle. Okay, now sine on the axes here? Well, we know sine is y over r. R is always positive. So really, it's just related to what y is. Okay, if we're plotting below the x-axis, y is going to be negative. Okay, so negative y down here, which means this sine of 11 pi over 2 will equal the negative of the sine of our reference angle pi over 2. And if you're not sure about that, try it on the calculator. You'll see sine of 11 pi over 2 is going to equal negative 1. And the sine of positive pi over 2 is 1, but then we're making that negative, and then it would check out. All right, good job. Let's take a look at a more typical diploma type question. Determining trig ratios from the point on the terminal arm. Yes, these are common. You need to know how to do these for sure. Okay, the point, negative 15.8, lies on the terminal arm of a rotation angle in standard position. Okay, so there's our point. They drew this for us, all nice. Okay, mark the angle theta. So if an angle is in standard position, it begins from the positive x-axis and rotates to here. See how we don't have a nice little triangle anymore. Okay, then they want you to calculate the exact length of OP. Okay, in other words, find R. Well, we could create a little right angle triangle here, which would be a good idea. This side length here, horizontally, would be our x-coordinate, so negative 15, y-coordinate, positive 8. So therefore, r would equal the square root. Actually, let me show where that's coming from. We have Pythagorean theorem, because this is a right angle triangle. R squared would equal to x squared plus y squared. So r squared would equal, x was negative 15 squared, plus y was 8, so we have 8 squared. Okay, add those two together, 225, 64, that should be 289. Okay, and then finally square root both sides to get r. R would equal, I believe, the square root of 289 is 17. Okay, great. So we've got our r. Now it says use x equals negative 15, y equals 8, and r from B to determine the exact values of the primary, that's sine, cos, and tan, and the reciprocal, which is cosecant, secant, and cotangent, trig ratios for angle theta. Okay, well let's do that. I'm going to change color. Here we go. We have sine theta is equal to y over r. Remember how I said we need to memorize these? You're kind of seeing that now, right? Okay, so y we know is 8. We can get that from here as well. And x is negative root 15, and r we discovered was 17. Okay, so y was 8 over our r, which is 17. And there we go. Okay, let's do cosine. We know is x over r. X was negative 15, r 17, and there's our cosine ratio. Okay, tan theta, y over x, almost said opposite over adjacent. We want to memorize these in terms of x, y, and r. So y over x, y was 8, x was negative 15, and we wouldn't want to leave our answer like that because we can't have a negative in the denominator, so we'll put the negative out front, and it will become negative 8/15. Good. Now, very easy to get the reciprocal. All we have to do, first of all, remember the name. So we have cosecant, CSC of theta, is just the reciprocal of sine. So that would be r over y. So we just take what we had for sine, and it gets flipped over. Or reciprocated. Okay, secant theta, reciprocal of cos, so r over x, and that would be 17 over negative 15. Don't want a negative in the denominator, so put it out front, and there's our answer. Cotangent, let me move that over a bit. Okay, cotangent of theta, x over y, and x is negative 15, y is 8. And there we go. There's our answer. All right, good job. That should make sense. Very typical question. Make sure you know how to do that. Let's look at the last example. Okay, our last example here is also a very typical diploma question, and therefore one of my test questions. So let's take a look at how to do this. Basically, this kind is we're given a trig ratio, and then they tell you some information. They don't exactly tell you where this angle A in this case would be, but they tell you cotan is this and sine A is negative. So here's what we're going to want to do. First of all, we need to figure out what quadrant we're in. Okay, so let's take a look here. We know that cotan, which is x over y, they're giving us here root 5 over 2, and it's positive. So in order for x over y to be positive, both x and y would have to be the same sign. So that would occur either in quadrant 1 or quadrant 3. So I put little check marks there. Then sine is negative. So sine we know is y over r, so it's really dependent on whether y would be negative. So where is y negative? Y is always negative below the x-axis, so in quadrant 3 and quadrant 4. The one they have in common, quadrant 3. So we're going to draw our terminal arm in quadrant 3. Okay, put a point on there, draw a little reference triangle. And now we're going to put this information that they give us. Cotan A equals root 5 over 2. We remember cotan and reciprocal of tan, which is y over x, so cotan is x over y. So what we know is the x is root 5 and the y is 2. So x root 5 and y is 2. But wait a minute. Okay, I know we went left and then down, so x has got to be negative and y has got to be negative. But how did we have a positive cotan? Well, x divided by y, negative divided by negative, gives us a positive. So there we go. Okay, so we must be in quadrant 3. Okay, and we basically already did what they talked about, labeling the diagram with the reference triangle. Okay, and now finally we need to figure out r. How are we going to do that? With Pythagorean theorem. So r squared is going to equal x squared plus y squared. It's like c squared equals a squared plus b squared. Okay, r squared would equal x, which is negative root 5 squared, plus ry, negative 2 squared. Simplify that. Make sure you have brackets around these things, because otherwise if you don't, you're actually going to get a negative when you square a negative rather than what you should get, which is a positive. Okay, so we should end up with 5 plus 4, which is 9, and therefore that's r squared, so r would equal 3. All right, now what are they looking for here? We've got r, that's good, and we want to find the exact values of cosecant and secant. Okay, well, cosecant A. Cosecant is the reciprocal of sine. Sine was y over r, so cosecant would be r over y. And do we have r? Yes, we do. That was 3. Let's write that up here. And y was negative 2. Okay, don't want a negative in the denominator, so negative 3/2. And there we go. Okay, finally, secant A. Reciprocal of cos. Cos is x over r, so secant would be r over x. R was 3, x was negative root 5. Okay, now we could leave that as negative 3 over root 5. Sometimes they might want you to rationalize that, so just do a quick little review. So go by what you see in the answers as to whether to rationalize this or not. See in your multiple choice choices. Okay, so to rationalize, you multiply top and bottom by root 5, and that would give you negative 3 root 5. Root 5 times root 5 is just 5, and there we go. That's your value for the secant of A. All right. Well, there you go. You should be able to tackle the lesson 3 assignment from your workbook and whatever else I assigned. And good luck, everyone. Thanks for listening, and we'll see you in lesson 4.